Welcome, mathletes. Let's do a little bit of work with the Pythagorean Theorem. We have a right triangle with leg lengths of 4 meters and 12 meters, and we're starting to be asked about the hypotenuse of the triangle. I have drawn a right triangle up here in the corner, and I put the legs and labeled them as 4 meters and 12 meters. The C, the hypotenuse that we don't know, is opposite the right triangle where it should be. And then we can start to analyze that hypotenuse. It has some restrictions on it. You probably already know that the hypotenuse needs to be the longest edge of the triangle, so it has to be greater than 12 meters. So that's the longest edge we have so far. But there's a cap for it as well to give us kind of an upper bound for things. So if we pretend that we could take our triangle and its two legs that we know everything about and open them all the way up so that things are oriented horizontally. It's like taking these two pens and tipping that height down so it's oriented horizontally next to the base. If we were to do that, you would start with your base of 12 meters, tip that height down so it's horizontally next to the base. Its length is 4 meters. And that means that those two added together would be 16 meters. That's the most the hypotenuse could possibly be. And that's the case in any triangle. If you take two of a triangle's legs and you orient them horizontally next to each other, that gives you a cap for the third leg. The third leg cannot quite equal that. So we know in our problem now that the hypotenuse must strictly be between 12 meters and 16 meters. And then we're asked to go find the hypotenuse. The Pythagorean theorem says a squared plus b squared equals c squared. Let's let a equal 4 and b equal 12. 4 squared plus 12 squared equals c squared. That means 16 plus 144 equals c squared. Then 160 equals c squared. You don't want to be tempted to stop here. 160 is way too big of an answer for this problem, and you know that because you've realized that the hypotenuse has to be between 12 and 16. You also should note that your c has a square on it. So we haven't found c by itself yet. That'll take one more step. We'll take the square root of both sides of this equation. We'll get the square root of 160 equals the square root of c squared. Simplifying this a little bit, the square root of 160, if we round it to a couple decimal places, gives us 12.65. And I'll put in an approximately here because we rounded, and the square root of c squared is just c. So our final measurement, rounded to the nearest hundredth, is 12.65 meters for our hypotenuse. Do our results from the previous two tasks make sense together? Well, we decided that the hypotenuse needed to be strictly between 12 and 16 meters, and it's at 12.65, so the results do make sense together. That's not a perfect double check, but it's a check for reasonableness. Let's try another one. Slightly different style. This time we have a right triangle with a hypotenuse that measures 12. One of the other edges measures 4. And you might think, oh, this is the same as the last one, but be very careful. It's the hypotenuse that measures 12 and one edge length measures 4. If we draw a quick picture for this one, maybe I let 4 meters be my height again, but 12 meters is the hypotenuse, so it's oriented opposite the right angle. The other edge length that we don't know, let's call it b. What do we already know about this other edge length? Well, it has to be less than 12 because 12 is the longest edge. So b is less than 12. And then if we imagined opening up this right triangle with these two legs, we'd have 4 followed by the leg that we don't know, and the most that that could be would be 12 meters. And that means that we only have 8 meters left for that B value. That means that your B value has to be strictly between 8 and 12. I'm having a hard time saying that phrasing today. Finding the length of the remaining edge, the Pythagorean theorem comes into play again. A squared plus B squared equals C squared. This time, A is 4, B is unknown, but C is 12. 4 squared plus B squared equals 12 squared. That means 16 plus B squared equals 144. Subtracting 16 from both sides of your equation leaves you with B squared equals 128. And remember that this is too big, and also there's a square on the B, so we're not done yet. We'll take the square root of both sides of the equation. And we'll only get one answer when we do this. Same in the top problem. We only get one answer this time because we're talking about lengths and they have to be positive. So there's just something to think about. When we simplify this equation, we get B is equal to the square root of 128. We are supposed to get a decimal value for this and round it to the nearest hundredth. And when you do that, you should get approximately 11.31 meters. Checking for reasonableness in these two tasks, we decided that the B value needed to be between 8 and 12, strictly between those two, and our B value ended up being 11.31. So it is reasonable compared to what we already know about this right triangle. So do our results from the previous two tasks make sense together? Yes, we have done a check for reasonableness.